Hey guys, welcome to another episode of Ferris Eats Burritos. By the way, the restart totally did work. I really don't know why that is. But at the same time, I'm kind of relieved because at least it wasn't something that like I messed up my setup or whatever and just forgot. That's not the case. So that's good. However, before we continue, I got a burrito and I would like to eat it. Because it's going to make me feel better throughout the rest of the stream and make me more productive. So I thought I could eat this off of the stream, or we could just hang out and sort of enjoy this burrito together. So I think that's what we're going to do. And then I think that'll also let people have a bit of time to sort of refresh their browsers and get synced up with the stream again. So yeah. Also, does Twitch actually run ads on this channel? I actually didn't know that it did that. Oh, I'm so relieved, actually. Bit of a rocky start, but that's okay. On one hand, it's kind of annoying if they're running ads on this channel, because I'm not seeing any of that revenue. On the other hand, Twitch is a pretty cool service that I am using for free. So that's nice. Guess it's a small price to pay. Especially since I usually turn on the stream like 5 minutes before I start. So I don't really have that much to complain about, I guess. Yeah, thanks for the suggestion, Mad Moose. Stack Overflow. Or your Stack Overflow foo is strong. Well, that's cool, Dom. Burritos. Buy them. Don't hire me for your ads. Yeah, it's Crayon. I actually made that a couple months ago now, I guess. Like, you can just make those communities. So I think I made that when the community thing came out. I'm trying to eat a little fast. Not too fast. But a little fast. I should have done this, actually. I need to get a bunch of like royalty-free elevator music. Because I feel like that would have gone really well here. Streaming scene is quite competitive. Sometimes you got to be able to up your game. All right. I'll be right back. Go wash my hands and grab a drink. And then we'll be off. Be right back. Okay. All right. So, last week, let's see. So last week I implemented something here. Let me see if I can actually pull up what I had last week, because I kind of want to show what I did wrong and then how I fixed it. All right, here we go. So this right here is what we ended up with last week. This is running in mnf in here. But basically what we're doing here is set everything up so that it will, the hardware will, or we have a little capture loop that captures all the values of the interrupt pending register. And what's cool about this is that then we can sort of draw these out like a scope. So this basically shows us throughout the period of a frame, these are when the different bits of this register are 1 or 0. Now the thing is, this is the interrupt pending register, so we actually shouldn't see it hold values. Like you see a lot down here. It's kind of hard to point with my mouse because the mnf hides it, but you can see these like long periods of time where it will hold a bit at 1, and that didn't really sit right with me why that was the case. So what I realized is that in my drawing code, I actually had this a bit wrong. I would basically go through all the different entries, which is basically all the captures of the different values throughout the frame when doing the rendering for this. And I would render these in sort of segments. And each segment would actually use the value at the end of the segment to draw the whole thing rather than at the beginning, which is totally wrong because then you'll end up with basically like a scenario here at the end where it's like, this value was actually 0 all the way until the end, and then it became 1. But what we end up with in this segment is just the whole thing ends up being high like that. So what this should have looked like, and here's the fixed code as well. What this should have looked like is something like this. Now this is a lot more like what we expected. So yeah, so I thought of this, like it was kind of bugging me after the stream last week, and then I woke up on Friday morning. I was like, hey, I know what's wrong. So sometimes that helps. Now, still between the different emulators here, things are still pretty different. Reality Boy is actually kind of close to the hardware. We'll get to that in a sec. Let me go ahead and pull up Rustral Boy as well. Now I may have to rebuild because I did a Rust update before the stream, so rebuild might take a minute, but okay, that's going to build here. But yeah, I want to show sort of the difference between these and also between the hardware, because I ended up getting a different hardware capture of this as well, which is quite cool. Let me pull that up. Mad Moose, it's possible, but I think it's going to be really unlikely, because especially with this register and then the other ones that we want to look at, when they go high, they're going to stay high for a little while. In this case, they actually stay high until we acknowledge them by writing back to a different register. So it's extremely unlikely that we'd miss one, because it would just go high and hold high until we basically tell it to stop being high. So at least for this register, I don't think that's going to be a problem. And my guess is that with the other states, as we watch a couple of the other registers, I don't think we'll miss any, because the resolution is big enough, basically. Or resolution is fine enough. I expect the states that we're going to watch to be held for long enough periods of time that shouldn't be an issue. What was I looking for? Oh yeah, my hardware capture. So all I did is, just like I was doing on the stream, I just stuck my phone in the Virtual Boy and just recorded. And the cool thing here is that we see, let me see if I can get this nicely visible. We see the same stuff that we expected. There's a little bit of timing jitter. This is, a lot of these state changes are triggered by actual analog hardware. So you'll see this will kind of go back and forth a bit, and it's a bit shaky too, because first of all, it'll kind of grow and shrink a little bit, and that's the mirrors on the Virtual Boy sort of syncing up and stabilizing. And that's also what ends up being reflected as these little timing differences here. But in addition to that, there's the parts at the end are kind of hard to capture with that setup. I don't really have a better setup than this right now still. I actually did look into that a bit, but at least the local shop didn't have two of the same webcam model that I wanted, so I'll have to dig around a bit more for that. But anyway, you can see that this basically looks a lot more healthy and kind of what we expect. But then when we start comparing these, let me see if I can just get a snip of this so we can sort of isolate just this. Because it doesn't change that much from there. Maybe not the easiest to see here with all the different stuff here, but what we have here, we have Manafin at the top here, and then Reality Boy, then the hardware, and then Rustral Boy. Now, what's interesting to note is that some of these kind of line up generally, like this one here, these line up, these line up. This one doesn't seem to agree at all. This bit here, we get it high here, and then it's never raised. Some of the left ones here actually flicker on the hardware. Let's see if that was actually one of those bits that does. Yeah, that one that actually I said didn't agree actually does flicker on the hardware. And so what I want to do here is I want to not just capture this interrupt pending register, but I want to do a couple hardware captures of particularly the display status register and also the drawing status register. And for this, I don't really care about the data from other emulators at this point, because they're all just kind of different in weird ways. And since we actually have hardware captures, we should really be looking at that anyway. So I just want to capture that Yeah, on the hardware again, and then see what we can find. So this is when the interrupts fire throughout the frame. We should see basically a direct correlation between the data that we see here and the other registers as well, because we see that basically the interrupts are going to fire on transitions between other states. That's what I expect, at least. So that's sort of the next step here, is to get this to watch. Watch other registers. So I'm just gonna like hard code this. I need to pull up the docs again to make sure that we end up watching the right bits. But yeah. Back to our sacred text scroll, because it's still the most convenient. Yeah, so this was the register we were watching. Now I want to watch this one, which is the display status. And I want to watch the drawing status as well, but we'll start with this. Now, interestingly enough, there's a lot more bits here. Actually, not too many more. Looks like there's actually only 9 bits that are really relevant here, just 1 through 10. That'll be helpful. So what we're going to do, first off, I actually want to see if I can get some captures here. So what I'm going to do is just make a little folder on my desktop or something. And we'll just start capturing. Yeah, so this will be hardware. And what was this? The interrupt pending. Is that int? I kind of want to get the name of the register here. Should be int pnd. I'm not sure which version of C. I think it's C99 or C89, I mean, because I have to do like the declaration at the top of the scope. But whatever. Yes, that's the hardware, and then I'll get this from Rustral Boy as well. Just snip these because I don't really care. Yeah, so then let's do this. So instead of, the first thing we want to do is we want to capture different bits here. I think 1, 2, 3, 4, 5, 6, 7, 8. We actually need 9 in this case. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And actually, in particular, I think what I wanted to do here, if we look at these, maybe I didn't do that actually. This just goes 0 to 15. I actually kind of wanted to flip these actually. You know what? I'm actually going to do that. So the reason I'm reversing the order here is so that when we compare it to the stuff in the documentation, we'll actually get these like top to bottom rather than trying to sort of mentally map those in our head. So I think that'll be a bit helpful. So like even here, if we just compare these two. The top one column, oh no, we need this here. Drawing exceeds frame period will never be set. The next one, drawing finished, happens somewhere around here. Drawing Y position match, in this case, never fires. Start of frame processing, start of drawing, right display finished, left display finished. And this ends up happening out here. It's kind of interesting. I'll run that in Reality Boy as well, just to get a little bit of a sanity check. See if these kind of make sense. Drawing exceeds frame period never happens. Drawing finished happens here. Y position match actually does fire in this one. Start of frame processing, start of drawing. right display finished and left display finished. You can see those left happens before right, which is kind of cool. So this to me at least like looks like it makes sense. And then display not ready never happens here. So this is nice. So I'm gonna run this on the hardware again. And that should be somewhat helpful, but it'll take a minute. This will be here. In the meantime, I can run this in Rush Tool Boy. I'll go ahead and, yeah, see here they're flipped. Go ahead and capture that. I guess I also could have inverted the images, but I want to see this just to make sure that it looks sensible. And when we get a few of these registers captured, it should be like very obvious correlation between them when the different states transition, and then when we get the interrupts, for example. I'll commit this too in the meantime. Push that. Good. So now I'll get a picture and transfer it. These pictures just look so funny to me. Not the smoothest cycle here, but way better than not doing this. So yeah, so while that's like uploading and stuff, I'll go ahead and actually change this to be the next one that we need. So this will be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Yeah, these 10 bits here. So here, we'll do 10 bits here. And then we need to change which one we're looking here. So we're not going to watch this anymore, so we don't need to ever clear this stuff. Although, actually, yeah, we do actually still need to watch this register because that's what we're using to synchronize everything. But that's fine. So we will actually do this. Where's my reg value here? So we need the regs, and then we'll do display status. We'll do this as well. I think that'll do it, actually. Not terribly complicated what we're doing here. Although it didn't work. Oh yeah, another thing I did here, by the way. Where'd my captures go? One sec here. Just to snip out the part of this picture that's important. Here's what we ended up with. Bit skeevy, but good enough to compare against. But I think I may not have done this right here. So we need to grab the interrupt pending register, and we need to wait till game start and frame start happen. Which is fine. Then we're going to reset the pending interrupts here. Then we grab the initial register value, which we're going to put in the pre value, which we compare against. And also we're going to append the initial value to our entries list. Then our capture loop still needs to watch this interrupt pending value because this is how we know when to stop. And yeah, they do, msys. So we're basically going to capture this every frame. We need to write it back to interrupt clear in order to clear those particular values. I actually don't think we need to do that since we're not going to be looking at that. And then, yeah, we'll get frame start here because we'll clear it initially up here, and that should be fine. Yeah, and then we'll grab the newer register value. If it's different, then we go ahead and capture that, and that should be it. Really quite straightforward. And it looks like this. Interesting. Just going to run this in a couple emulators. Interesting that these ended up being held. There's even a little bit of jitter here. That's fun. And Rush Dual Boy actually looking quite similar here. So my guess here, I don't remember exactly what these bits were. But we have, for example, column table address locked. Never happens. Display sync signals enabled. Seems to happen here. Some of these I don't know if I actually emulate all the way either. VIP memory refreshing. Yeah, I never emulate that. Display procedure beginning. Display is ready. Right frame buffer being displayed. It's a bit odd. Not sure if this captured right. I'm seeing like right FB0 and FB1 being displayed. I think those should actually be swapping when I think about it. Interesting that they're not. It's 5F820. I just want to make sure that we are actually looking at the register we think we're looking at. Oh yeah, here we go. We actually grabbed the interrupt pending register. I didn't update these. That should help. I hope. All right. This is actually what I wanted to see with these two alternating. Because it's basically whether or not it's displaying out of the different frame buffers. And those frame buffers should actually swap every frame. So we should actually get this kind of flicker. So yeah, this looks a lot more sensible, as well as you see a lot of these registers are actually being held at 0 or 1 throughout long periods of time. And that's what I would have expected here. And we should see as well some correlation when we look at like the hardware and stuff between these captures. For example, where did I put that window? Here. If we pull up the interrupt pending for Rustro Boy, we should totally see some correlation here between when it changes some of these states and when these fire. So for example, I think this is like the left frame buffer display finished, and this is the right frame buffer display finished, and that corresponds exactly to when these display periods are done, which is really nice. So yeah, this is actually more or less exactly what I hope to see from watching this register, so I'm happy about that. But we definitely need to get a capture from the hardware, so I'm gonna build this. I'm gonna do a transfer. And while that's happening, I'm going to grab the capture from Rustro Boy. Now, this is only going to get one of the 2 frames, as you can see here. And which one we get is basically luck of the draw. And I'm just going to have to remember that, I think. So the most interesting one of these, of course, will be what the hardware actually does as it transitions through these states. I still expect to see these flicker in these same bits. A lot of these are still going to be held high. But where exactly these happen is going to be particularly interesting. And once we've captured display status, I would also like to capture drawing status. And with those, we hopefully have enough to at least start moving things around in the emulator to try and match the kind of timing, at least on a high level. And it should be pretty cool. All right, already getting some interesting stuff. A couple things I didn't expect already, actually. Which may be quite interesting. Also, the flickering totally happens on hardware, and it's visible to the eye, but when I actually try to take a picture of it, it kind of got blurred. But that's actually a pretty good middle ground, I think, in terms of the information that we actually want to glean from this. So I'm satisfied with that. Kind of waiting for that to get to where it needs to go. Trying to more or less match the size here, so it makes it easier to compare. Oh, Rubnop. That sounds hardcore. Yeah, so already here, this is actually really cool. We can see, it might be a bit hard with these two. Might be a bit hard in this form factor. But I can tell you right now, there's already a correlation here. If we look at these two here, we can see that this bit here, which is left display finished, and this one, which is right display finished, matches exactly with when the left one's here finish and when the right one's here finish. And that's exactly the kind of correlation that I wanted to see. The other interesting thing is that these here, both of the display periods here, seem to actually take up about a quarter of the frame, which is more or less what I would have expected. But what's interesting to me is that they're not like synced with the other signals. They're like offset by like an eighth of the frame time here, which is actually pretty interesting. I didn't expect that, but it totally lines up with the timing here. And also it kind of makes sense, I guess, if it's going to like use half the frame to display the left, half the frame to display the right, or for example, then that could actually make a lot of sense. But yeah, a bit different than Rush Jewel Boy, where it would display sort of in the middle here, because it's all based on those quarter frame intervals, which made it easier to code. But yeah, so that's actually pretty cool. .178 because I'd rather just hack it, to be honest. Making it configurable would maybe save a little bit of time transferring it to the system. But that's like all it would save, so I'd rather just hack it. I'm going to put the different versions of this on different branches, though. So now instead of the display status, we want to watch the drawing status. I think drawing is XPSCTS, if I recall correctly. And that should be the only change. Yeah, just doing some more data collection. And seeing the correlation a little bit. Which will be particularly interesting, I think. So this is the drawing status, which looks quite different than I would have expected. Let's see what this looks like in Rush Boy. Rush Boy and Midnafin look quite similar. It looks like Reality Boy does some like incrementing of this register value, because this looks like stepping of binary values here. That's somewhat interesting. The jitter is also somewhat interesting. But let's see what the hardware does. That'll be the most exciting thing here. Let's go ahead and dump that onto the hardware. And in the meantime, I'll capture this. So yeah, really not very exciting from Rush Boy here. Yeah, Cobol sounds brutal. Particularly because of the environment that Cobol is still used in. I gotta say though, I'm still really satisfied with with this method to capture data. This is working out really well, I think. Also, I'm totally, on another level, totally enjoying spending my Thursday evening with the Virtual Boy before tomorrow morning, where I go to Sweden to spend all weekend with my C64. That'll be pretty fun. Oh, I didn't realize there were two. Yeah, I set up a Slack reminder on Monday to remind me to buy that. I like to do that to decide whether or not I actually want to buy something. I just set a Slack reminder for a few days in the future, and then when it goes off, if I still want it, then I buy it. All right. So now let me take another picture. Oh, I love watching this stuff. All right, that's uploading. But yeah, thanks for that tip or two. That was a cool tool that one time we used it. The only thing holding me back is I don't know how often I'll use it at other times, but it was really useful when we needed it, so that's probably something I'll end up buying. Just a great tool to have around. So yeah, I'm just gonna wait for this to be transferred, and then we'll have all the information that I actually wanted. I should at some point also go and get these. Hold up here. Oh, you know what I totally didn't do though, actually, on this last one? I may have done this wrong because we watched the same bits as the display control, and they're probably not the ones we wanted to watch, actually. So I'm actually going to recapture this. That's totally my bad. I totally messed that up. Didn't think about that. So yeah, that was a bit useless. But okay, this will be easy to fix. So we're going to do the same thing here, where we want to watch the drawing control rather than the display control, but then we need to change which bits we look at. So in this case, there were these 10 bits. I think drawing status has a lot fewer. Although we do have this 12.8. So actually, this is probably the current Y position thing here. That's probably what maybe I'm trying to say. That other one. Why am I thinking of this? Reality Boy was trying to emulate, although it must have been in the wrong bit positions. So that was kind of weird. But let's just see. So we need 15, 12 through 8. Uh, 4, 3, 2, 1. That's again 10 bits, so this should basically be it. Not much interesting from Maneffin. Reality Boy, yeah, then we still get these counters. Really weird stuff here, though. This we actually would expect, though. Seeing the Y position to match many times. This happens 20 times. I think it should happen 28 when I think about it. But yeah, let's see what the hardware does. Also, this is what... also not much interesting from Rush to a Boy. So yeah. Yeah, so I need to recapture this on the hardware. So yeah, well, this ended up being the same, actually. Which just goes to show how little of this register I have implemented in our emulator currently. I doubt that's going to make much difference in a lot of the games, though. But it might. It might. Although I really think the scheduling is our biggest problem. What I might end up doing, depending on the granularity of the changes in the drawing status as well, is particularly split this up into eighths of the frame to be able to do this nicely. See you later, Rep Knob. Appreciate it. And then we'll see what else we need. And if I can get a better sort of capture setup, particularly I want a dual webcam setup for the hardware, then I actually want to re-record a lot of this stuff, but do it with actual video. Doesn't look that much different. But I got some peace of mind from doing that again. So we'll let that transfer. And then, oh, that was a lot faster. And we'll crop this as well. Kind of eyeballing it here. Should be fine. All right. So what I want to do is I want to kind of line these up. I'm going to pull up Photoshop. And I want to, yeah, like I said, just line a bunch of these up and just start seeing where we can get these actual state changes. Particularly, I'm just looking at the hardware here, not the Rush Boy one. And the reason is I want to sort of make a kind of spec sheet to where we should be. And then we can use the Rush Boy captures to sort of see particularly where we're really different. And how we can improve here. So I think this will be cool. So, oops. So this is our display status. Oh, Nixion 40, I think. I don't know how you say that. Thanks for the follow. So yeah, we're gonna do something like this. So a couple things that are interesting, just to draw on some like guidelines here. This is where stuff should get decently interesting. I'm just gonna merge these, by the way. Actually, I want to do a little bit of room around this. Just so that we get some room to mark stuff. Whoops. Okay. So a couple interesting things here. We're gonna draw lines here. On this episode of Ferris is bad with Photoshop. Screw it, we'll do rectangles. Do blue. That'll be easy to see. Yeah, so a couple interesting things here. Here's one. See that these correlate. We'll do another one of these. You'll see that these correlate. So these are going to be the display finished registers here. I don't actually know what these bits are, which are kind of interesting. I also noticed there was some flickering basically on the end of both of these on the hardware, so there may be some interesting stuff there, but we'll see. Might also just write in all the different things here, just to add some of this text. In my in the Ferris Stream stuff font, of course. I'll use something fixed with, like Consolas is a nice one. Maybe Photoshop isn't the best tool to do this in, but this will be fine. Also, I think I should scale all this up, actually, just seeing that. Whoops. What happened there? Here we go. Don't want to rasterize these. Oh, I totally will, Studio C. When we fix this bug, I'm going to be so stoked. And I'm totally going to include all this stuff. And I do say when, not if. We will totally fix this. By the way, what is my... About 400 pixels? Yeah, let's make that 3 times the size. Kind of big, but no worries. It'll give us ample room to actually place text. Good. Good. Something like this. So up top was our display status. I was gonna actually change the alignment here. This will be easier if we align it to the right. Go ahead and dupe this. This right here was our drawing status. And then finally we have our is there not a hotkey for duplicating layers? Because that's like one of the things I do so much in Photoshop is just duplicate layers. So much. Yeah, so these are kind of our different registers. I'm so happy at least this correlated. I was hoping to see a bit more, but I think this is okay. I guess copy and paste just works. If we can do it with the whole layers. It's kind of what I'm worried about. Control J. Oh, yes. Thank you, Studio C. Control Alt J is oh, that's nice. That's good stuff. Yeah, thank you. That'll be really helpful. So yeah, we'll do this, and then we can start sort of labeling the different bits. With this curved one, it'll be kind of annoying, but I think that's fine. So I'm gonna pull up the docs, and I'm actually gonna pull them down here because it's gonna be Even though you guys can't see what I'm pulling the data from, I mean, it's the same data, so should be fine. Actually, it looks like I cut off one of the bits at the top. Either that or it's always 0, which is column table address lock. So that's probably what that is, actually. Need to move this up a little bit. It looks like. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bits, which is what we watched. And yeah, so like something like the display sync signals enabled should always be enabled. So that's looking good. Oops. I'm going to live in this hotkey. Yeah, get a little shafted with the resolution here, but it's going to be okay. Here's VIP memory is refreshing. So interestingly, that it seems to always be on. Hopefully, I didn't screw that up, but we'll see. I honestly would not be surprised if it would do memory refreshes like on a different clock phase or something than the rest of the accesses, so it might actually happen all the time. So yeah. Display procedure beginning. Just going down the list here in the docs. Display is ready, which should always be on again. So getting some good sanity checks already just by looking at some of these values, which oh, that feels so good. I gotta publish these as well. Yeah, so here we should get the left and right frame buffers being displayed, which is exactly what we expect. Oh, so nice when this is lining up. Gonna be the left one, I'm sure. Yep, and that's why we get the. So these is gonna be FB1s and FB0. So we're gonna get left FB0, left FB1 one frame, right FB0, right FB1 on the next frame, back and forth. Yeah, I just need that enhance. That's exactly what I need here. Right FB0, I'm writing before I check. Yeah, that's right FB0. And then we'll do left FB0. And then the last one is going to be display is enabled, which should also always be on in this case. So this actually looks really good in terms of what we would have expected for these different bits. So I'm thoroughly satisfied with that, to be honest. That's really nice. Just to differentiate these a little bit, by the way, I'll make this bold. Well, I probably shouldn't have done that because I'm just going to dupe it and then have to change this one, but that's fine. Here again, it looks like I also have another bit up here. that I missed, which is fine. Do this like that. All right, so now we're on drawing status here. Now, it's interesting that this one never fired on the hardware, even though it triggered a lot in Reality Boy. It might just be that I never enabled whatever that is, or maybe we're missing it somehow. Not entirely sure about that, but it was stable when I was looking at this. So yeah, on the right track, I think. Oops. Yeah, and then the next couple were the Y position. That I would have expected to change a lot more, actually. Like, that one concerns me a bit, but we'll move on there. And for this, I'll just dupe this a bunch of times. That's 12, 11, 10, 9, and 8. And then after that, we have drawing exceeds frame period, which we totally expect never to fire in this case because we're really not drawing very complicated stuff. Here we've got writing to frame buffer 0, which is also interesting because it looks like we missed it. And that I'm not very comfortable with either. Bit surprised about that. So I think I duped that twice, by the way. Yeah, I totally did. In this case, we had writing to frame buffer 1. Yeah, this is totally what that is. And then we have drawing is enabled. Now, I wonder, actually, because then bit 0 is not used. I wonder if I misalign this. Something like this. Does that still make sense? Then I really don't like the writing to frame buffer ones. It really looks like I had another line there. This is not good. I'm a bit skeptical about this one, to be honest. Let me go ahead and double check my code here. 11, 10, 9, 8, 4, 3, 2, 1. And here we were looking at XP status. It looks correct. Just to be absolutely sure. I would kind of like to just rebuild this just to see. Okay, I got the recipe for the target failed, which means I need to delete the build directory again, if you guys remember this bug. So I may have messed up the capture of this register. I'm feeling good about the others because they totally lined up with what I expected. But this one, I'm probably going to do again. And that's fine. That's okay. So yeah, hardware tests, reg scope, just delete builds here. And the other thing about this that makes sense is we didn't see, I ran this in Reality Boy a couple times, and when I changed the bit indices, it didn't look like it changed. And that could be a sign that it didn't actually rebuild. Here it looks about the same, but let's just do this anyway. It's totally going to be worth doing this again, even if we learn that we had it right. This is quite cool, though, watching this come together. I need to show this as much as possible on the screen so that it ends up being available when I get to pick my screenshot. I could totally just edit one, but yeah, don't want to do that. Particularly what I'm concerned about here is that we're also not seeing sort of any correlation between these two. And I would really like to see, for example, these blips here actually mean something. But yeah, this top one looked really good. I feel really good about this one. Wait for that to finish. I'm going to run this again in Retro Boy as well. Yeah, it didn't change much, but still. Okay. So it looked like this was actually correct, and there is another line up here. So this is a bit odd. Plaid Astronaut, thanks for the follow. So this is the drawing status. Again, we had bit 15, drawing at the Y position. And this does actually flicker on the end in the hardware. Then we had 12, 11, 10, 9, 8 for these bits. Drawing exceeds frame period. Writing to frame buffer 0. Writing to frame buffer 1. Drawing is enabled. And then why is there another bit here? What am I missing here? Oh, you know what it might be, actually? No, that is 10 bits here. Doesn't this seem weird? Now I know it rebuilt it because I deleted the build folder. And the file dates look correct. But I'm kind of thinking, what the hell? Let me count these on the hardware. Yeah, there's totally 11, and there totally are on the hardware as well. Which really bugs me, because like this totally lined up. That should have been 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you include the top one, which it totally had. So this is weird. I definitely have, looking at the code here, whoops. I definitely have 10-bit indices here. There's a loop down here where we loop through different bits, and that goes 0 to 10, as it should. Just missed who followed me. Sorry, whoever followed me. I totally missed my window was behind another window. But thank you. So this should work fine. Why do we get another one? What could cause that? The other thing too is there was some flickering in terms of like the timing of the bars here, but it was still pretty stable. Very strange that I'm getting an extra one here. This one here, it does something like, goes like this and then kind of bumps up. Acts a bit strange, but it should still be fine. Not entirely sure what would cause this. Let's try something here. Let's mask off this top bit in case something is happening. I can color each row not on the system. In Photoshop I can, but let's try something here. If it were getting too many entries here, that could cause a problem. And in that case, perhaps masking off some of these bits might help. So let's say, for example, that we masked off the drawing at Y position and the current Y position maybe. So let's just take the bottom 5 bits and just see if it changes anything if we only look at those. So to do that, we'll just do and 0x1f. And we can do the same thing later when we grab it. Or actually earlier when we grab it here. Yeah, the woes of a Sakis312, thanks for follow. The woes of a binary binary system here. Here there's only 10 now. just to be sure here, because I actually think I might know why we would get more if that's what's happening. If I don't mask off these bits, I might actually be able to explain this. Here's 10 again. Or actually, I could do a number, but the reason I'm hesitant to do that is then I have to add numbers to the font. Here's 10 here. I'm just going to try running this on the hardware really quick. Kind of weird that we're getting a different result there, particularly. Particularly. Yeah, I could make the full bits less tall. Yeah, I could draw each number in binary, I suppose. Only need 4 bits. That might help. That's clever. The reason why I'm trying to mask out these bits is I'm actually somewhat worried that it's like overflowing. Like if it captured a bunch of changes to one of these values that we, like they may happen at the end or something and we didn't catch them or we didn't render them correctly, it may overflow onto the next row. So it's a bit of a long shot, but it might actually make sense. I'm just trying to think of why it would draw another row, and I'm a bit confused as to why it might actually do that. So maybe this makes sense. Remember, on a system like this, nothing's gonna... there's not going to be like a memory access violation or whatever because we don't actually have an MPU. So reading outside of stuff is going to be sort of extra dangerous. So we are still getting like an 11th row down there. And nothing else has really changed. So that's annoying. However, I can say one thing about this. That the alignment here is actually correct, I think, because these bottom 2 are flickering, and we see that in all the emulator outputs as well. These bottom 2 here, and then this one's solid. So somehow we get something else beneath. I don't know what that is, but I think all these should actually line up with what they show here. And I think I'm going to add a note about that. But beyond that, I'm going to see if I can not look into this and get away with it for the time being. Because it's weird too, because it fills up almost like some kind of progress bar. It looks like when it's on the system. So not sure what that is, but I need to save this before I lose it. So yeah, a bit surprised we're not seeing correlations here, but let's write out what these bits are. Maybe that will show us something interesting. I'm kind of avoiding the issue because it's really bugging me. So I'm pretty sure I clear the memory, but I clear the screen memory before the program starts, I believe. Maybe I don't. But the weird thing is that I shouldn't be writing there. That's the weirder part. But yeah. Let's see here. So this one is I'm kind of wanting to avoid it because I don't want to spend all night on that, and I am the kind of guy to do that. Let's try to move forward here. It's weird too that it only happens with that one, but I'm not sure what the deal is there right now. Drawing finished. Drawing Y position match. So it is actually interesting that we get this twice here, which actually could make a lot of sense here if we would get it for left and right. Although I can't remember if I determined that that would happen per column or once per frame. I think I actually had a note about that in the code. But if we have two of these, that would actually totally make sense why. So that's pretty cool if it draws left and then right. Let's see what else we got here. Yeah, and there's actually bits on the left here. It's kind of hard to see, but that's what we have there. And here we have the right display finished and the left display finished, just like we expected. That correlates to those, which is good. And then finally we have display not ready, which is always low, and that's what we expect. So this one looks really good. So we might actually have to finish looking into this actually, because I really like this drawing Y position match thing is particularly interesting. How we get two of those. That kind of bugged me seeing that before, but now seeing which bit that is, that might make sense. However, I really would have hoped to see some correlation between the bits here and the bits down here. So maybe there is some issues that we're having. And if we fix those, we might have to recapture everything else. Although, again, at least these lined up, which was pretty cool. Nah. Trying to think of how on earth that could happen. Because even if we didn't like clear the memory, it shouldn't fill up like it does. Like it fills up progressively. And that would mean we're writing there. Which is disturbing. Interestingly enough, this is what it looks like in Reality Boy. We get a lot of these drawing at Y position ones. Where's the best place to put this? I guess here, because we're not really seeing much useful there anyway. And the current Y position counts out a bit pattern like this, which is also kind of what I expected from the hardware. And then drawing seeds frame period never happens. Writing to frame buffer 0 and 1 happen at the end, which I don't expect is correct, to be honest. But yeah. It does kind of look like a castle. The top here especially. It's a bit sketchy. The other thing that's actually really concerning is it doesn't do it on any of the emulators. It only does it on the hardware that it drew the extra column. That is quite disturbing. Or drew the extra row, sorry. Not really sure what that is. But I actually think I might cut the stream off here. The top row maybe it's possible that we end up with something like if this one actually changes a lot and it's not rendered correctly, then it might overflow to the next one, and that could cause some issues with the other ones. Really not entirely sure. But yeah, I think I'm gonna call it quits for now, and we'll either look into this next week or hopefully get some inspiration during the week, because I actually got to go pack and stuff. But from what we've gained here, this is actually pretty cool information. So I'll just add this as a sort of note to self here. Yeah. And then I think we'll continue on this next week at the latest. And if I end up figuring this out or working on this until then, you guys will surely hear about it. But yeah, I think this was super useful. A bit slower than I had hoped, but at least seeing the correlations between this one and this one is really nice. And then the fact that this might be drawing position match would totally explain why we get 2. So I'm really happy about that. So yeah, I'm fairly satisfied. We got a little bug at the end here, but I think that might be interesting to look into anyway. So yeah, thanks for hanging out, guys. And I will see you guys next time. Not on Sunday, by the way. But next Thursday we should be back on this. But yeah, see you later, guys.